and label the parts of the power using vocabulary, base, and exponent. So we're going to simplify this first. You do not need to write negative 2 times 5 times x times x times x times x. What would that be simplified? Nope. There's 4 of them. Okay, negative 10x to the 4th would be the simplified version. This is expanded. This is actually third. And this here would be simplified. Now, out of this, the negative 10 is a coefficient. Negative 10 is a coefficient. Out of this, what is the base? X is the base. And that leaves us with what as the exponent? 4 is the exponent. Okay? So 4 is not on the coefficient. 4 is not on the negative 10. It's only on the base, which is x. Okay? Now, there's all the whatever the exponent is on is called the base.
So it could be anything. It could be a 10.
You could have 10 to the 7th.
And the 10 could be a
This would be a base. Yep.
It could be like y to the 7th. In the y.
And if I had xy to the 7th, xy would be the base. It's whatever the exponent is on is the base. Okay, so rules for exponents. These are rules that you kind of learned in Algebra 1 and sometimes remember and sometimes forget and sometimes make our goal with this when we add in the Algebra 2 and the more difficult stuff that you still know these rules and still use these same rules. So we have something called a product rule. And in order to do the product rule, I like to give you one that I know you can answer really easily. X squared times x to the 3rd. Let's think about that. X squared is how many x's? Okay. X times x. X to the 3rd would be x times x times x. If I actually multiply there, I 5th. So what is that shortcut rule about if you are multiplying like bases, you do what to the exponents? Okay, this is right here. If this is, and they have to be like bases, the bases have to be the same, then you put exponent over here. Quotient rule. Something like x fifth, x second. So x to the 5th is 5 x's multiplied together. X to the 2nd is 2 x's multiplied together. And what happens?
X to the 3rd.
We get x to the 3rd. So the rule is saying if we have like bases, then we subtract their exponents. And you always subtract the top minus the bottom. So if I had, I'm going to give another example. I'll throw it over here on the corner. If I have 2 to the 5th over 2 to the 6th, if I subtract these, I get 2 to the 5 minus 6.
So 2 to the negative 1.
It would be 2 to the negative 1.
But you can have negative exponent.
We're not going to leave a negative exponent, are we? Now, if I did this a different way, if I wrote all 5 2's out and I wrote all 6 2's out, I should probably made it numbers that were easier. Can you guys stop playing around? It's really easy to not play around. If I expanded all of these out, here, I'll make them easier, and I'll actually expand them. I'll make it a 2 and a 3. It's going to be the same thing. If I expanded that out and I had like 2 times 2 on top and I had 2 times 2 times 2 on the bottom, and we canceled out, I would have left over 1/2. So we are going to go over that these are the same number. We're going to go over that. But I did want to make sure that you know you always do the top minus the bottom exponent, and sometimes they could be negative.
Wait, how did you get the 1/2 again?
I did it a different way to get the 1/2.
So
We-
you're saying that negative 1 is
I remember doing
equivalent?
this in 8th grade. This is saving.
Oh my gosh, oh my gosh. Again, I'll say this. I'm going to go over this today. Come back to this. All I want to make sure you know is to subtract the top minus the bottom. We will go over that today. Okay? Okay, we'll get there. All right. Power rule. Power rule is when we have a power, which is like a to the m, or let me make up one, x to the second, and we take that to another power, to the third. Now, if you don't know the answer to that, I'm going to write out x squared times x squared times x squared.
Isn't it x to the 6?
That would be x to the 6, wouldn't it? So what do you tell me about the rule? If we have a power to a power, we multiply the exponent. Okay, and then here's another example. Look, they have negative exponents. They have y. Raise that to the positive 21st. That's just following rules right now. We're not necessarily understanding what the negative means yet. Raise to a power. It's power of product. That means I've got 2 things multiplied. So let's say I have 3x, and I'm going to raise that to the second power. What you do is you raise, actually let me do it the long way. If I'm doing 3x squared, I would be 3x times 3x. That would give me 3 times 3 and x times x, which is what? 9x squared. So that's like the long expanded way, which works. Their shortcut rule, the shortcut rule says if you are raising a product, this does not work with a sum. This only works with multiplication. If you're raising a product, then you can take each individual piece to that power. So you can do the 3 squared and you can do the x squared separately. That does not work in this case. It does not work there. Remember, I have that written on my board over there. You cannot do it that way. What would you have to do for a sum like this? Did it a lot last semester. What would we have to do to multiply these? To multiply them. Yeah, you'd write it twice.
3x squared will be.
Are you still on this over here?
Yeah.
Okay. Yeah.
No, I'm just asking because I looked up and then you just already been doing it, so I was just asking.
The answer is x squared plus 6x plus.
Right, that's the right answer for that one. But I'm just making you guys remember that this does not anything. This only works for when it's multiplication. That's all I was trying to say. It does not work always. All right, and then the next one is quotient to a power. So, sorry.
3x squared was
9x squared.
9x squared?
Yeah. So the next one is a quotient, and because division and multiplication are basically the same thing, I can use the same shortcut that says if we're dividing attribute that power to both the numerator and denominator. This will work as well. An exponent of 1. If I have anything to the first power, what is 7 to the first power?
7.
It's itself. No. Oh, I put it in the wrong place, though. What if I have negative 357y to the fourth all to the first power? Negative 357y to the fourth. And of 0. 9 to the 0. Oh. Negative 25 to the 0. Anything to the 0 power equals 1, as long as you're not doing 0 to the 0 power.
Why is that?
I don't know. I'll get back to you on that one. I forget. It's very deep math. Negative integers as exponents. Okay? This is where I said I was coming back to that. When we have an exponent of negative 1, this is directions. It tells us reciprocate the base. So if I have x to the negative 1 and I reciprocate, what is the reciprocal of x? Say that again, Katie. 1 over x to the as 1 over x. Let me show you this pattern. 1, 2, 4, 8, 16, 32, 64. Does anybody know what I'm doing in this pattern? I am multiplying everything by 2. Actually, time. I could actually write these as simpler, saying second. This is 2 to the third, 2 to the fourth, 2 to the fifth. Let me go backwards. If you follow my pattern that I wrote in red, what would this be? Is anything to the 0 or 1? If I'm going this direction, I'm not multiplying by 2. I need to do. Okay, so if I go 2, my next number down is a half, and then 1/4. Let me follow the exponents. If I have my exponents down by 1 each time, negative 1, what's this one going to be? This will be 2 to the negative 2. So the negative part itself is the reciprocal. The number by the negative tells us what power to raise it to. If I have 2 to the negative 2, which I do right here, if I have 2 to the negative 2, that says I'm going to rewrite it. I'm going to pull apart the negative sign and the 2. 2 times negative 1 is negative 2. Is that correct? Is that correct? 2 times negative 1 is negative 2. Is that correct? Okay, so what I did, I'm using, it's the power rule, just backward. Okay, so now I have 4 to the negative 1. And what's negative 1? It says reciprocate, so I get 1/4. 2 to the negative 2 is 1/4. You should have covered this material at some point, but you probably forget a lot of it. So that's why we're taking a whole day to review things that you should know. I have this chart. This is my what to do to the exponents chart. Normally we think about order of operations and we think power, exponent, multiply, divide, add, subtract. So that's not power. I'm in parentheses. PEMDAS, yeah. So the parentheses, that's not really part of my chart. This is just exponents, which is power. This is the E. See, I wrote an E right there. Exponents are also roots, which we haven't learned about. So anything exponents are powers and roots. We got multiply and divide, and we've got add and subtract. That is the order of operations. And then I have this blank one right here. This is kind of a visual tool to help you remember what do you do to the exponents. Question? Yes, but that's not in my chart. That's why I crossed it out. Parentheses, you would always set up my operations to set this up. So now, doing, and we did this on the first page, if we were doing x squared to the, or would you? So this is how I would use my chart. I would say, I am doing power. I'm doing an exponent, which is here. Out on the outside is what I do to the actual exponents. So if I'm raising the base to a power, then to the exponents, I multiply them. Yes?
I thought P was parentheses. Oh, we did?
Okay, so that's probably somebody else missing it too. Order of operations, P is parentheses, yes. I'm not including in my chart. When we do order of operations, we always do powers or roots first, but we don't know about this yet. We do multiply, divide next. We always do add, subtract. So I'm just looking at the operations. I'm not looking at parentheses, okay? Now, the thing on the outside is what the exponents do. Let me give you another example. If I have x to the third multiplied by x to the second, you say, what operation is happening on like bases? What operation on the bases? Okay, so we go to multiply. So what are my exponents doing?
Adding.
Whatever's underneath, add. So the exponents do kind of one level below doing. So what would that look like? Bases were being added. X to the fourth plus here, 2x to the fourth, x to the fourth. 3. What?
Are we still on the X with their power?
Different examples.
Oh, okay.
Example, the third. Just how I start.
Because, like, the answer would have been the X to the fifth.
Mm-hmm. Yeah, I just didn't finish it, sorry. Okay, so this one here. What is happening between my like bases? What operation is between my like bases? See how this is an addition. Now you guys should know, if I add together like terms, what would this answer be? You should know this already.
3x squared.
Try again, Martin. So if I add like terms, what do my exponents? Nothing, right? They stay the same. So that's why whatever's underneath your order of operations is what you do to the exponents. Okay? So if I were dividing, here's another example, new example, x to the 7th divided by x to the 5th. X to the 7th divided by X to the 5th. If I'm dividing, what should I do to my exponents? Subtract them. So I do X to the 7 minus 5, which is X to the 2nd. And if I'm doing a root, which you don't know how to do yet, what do I do to the exponents? I divide them. But we don't know how to do that yet. We'll cover that when we actually start chapter 5. Okay, so that's how you use this chart. If you want to use the chart, put it there. Some people are really good at memorization, and some people don't remember these rules and they mix them all up. So that's why I have that chart there. Anytime the exponent is 0, the result is 1. If the exponent is -1, this means to reciprocate. All right, let's do some examples. When we do examples, I like to separate by numbers or letters. I like to look at things separately. So 5 to the 2nd power, can we simplify anything there? 25. X to the 3rd, nothing to simplify. Y to the
1.
and Z to the 4th. Okay, and we just multiply all that together, 25, X to the 3rd, Z to the 4th. 2. What's Y to the 0?
1.
So if I multiply 1 by 28 and by X to the 3rd, 28 X to the 3rd, right? Oops. All right, the next one. X squared times an X times an X to the 4th times an X to the 3rd. I notice right away everything here has the same base. What? Oh, you're telling me the answer. Everything has the same base. So if I am multiplying same bases, if I'm multiplying the same bases, what does that mean I do to the exponents? I do the thing underneath. I add the exponents. So I'm adding X to the 2 plus, what's my next exponent? That is a 1 plus 4 plus 3. X to the 10. Oh my God, this is so easy. I already have it all done. But not everybody's there, so I'm going through each of these. They will get harder. I promise you, I will give you challenges. Okay? I promise. If this is the challenge, it's going to get really challenging. For this one, what am I squaring?
2 and 8.
No, it's 2.
Am I squaring the 2?
No, it's just the M.
How would it look if I was also squaring the 2? Yeah, I would have parentheses. So, like, make it bigger? You need to get glasses, dear. If there's parentheses, yeah, you'd square both of them, but there's not. So I'm only squaring the M. What was your question? Go ahead. Yes. So we will add the exponents of our like bases, and we'll multiply the coefficients together. All right, next one. You can multiply coefficients. This is all multiplication. You can multiply -5 times -2 times 3 times -2. Now, I was able to do that because none of the coefficients had exponents on them. Yes, dear?
They don't have like terms.
Some of them have like bases. Like terms are different than like bases. So the A's, they have like bases. So how many A's are we multiplying when we do A squared and A to the 4th?
-5 times, right?
The coefficients are different. You can just multiply all the numbers, all the coefficients separately.
It's a squared times a to the 4th, so it'd be a6.
Right. Yeah, we're doing A squared times A to the 4th which when you multiply like bases, yeah. So let's look at the y's. I have a y here, and I got a y there. So you should have a y squared. So we do them separately. It's different if there's addition signs in here. If it's all multiplication, you're just doing them separately. All right, next one. No. Because by order of operations, you do power before you do multiplication. So if I'm doing power, what does that mean we do to the exponents? If we're doing power, we multiply our exponents. So I get 3 times x to the 4th, or 3x to the 4th. We're going to run out of time, aren't we? Awesome. So I'll hand out your worksheet. We didn't get through all of them. I will try to record a video and go faster in my second class. I have a recording here, but I'll try to go faster in my second class.